Hi, the purpose of this lecture is to talk about additive manufacturing, its development, and the different types of additive manufacturing processes that are out there. When we develop a new product, it's always a great idea to take it from the design concept to a functional prototype so that we can actually see how the part is going to perform because in developing a new product, particularly anything of scale, of volume, um, you're going to invest much money in capital for new production facilities, assembly lines, and so on. And that's very, very expensive, but it would be sure nice to, before we go through all that expense, to see if we can't come up with a prototype. So since I've been around for a while, I've kind of seen the evolution of rapid prototyping, which now has the uh, um, much more attractive term of additive manufacturing. But there's always been the need for a prototype before we go into actual production. For example, I worked on many, many years ago, I worked on the detailed design of the Seawolf submarine. Which was a fast attack submarine. And that was at Newport News Shipbuilding. And we actually had a full scale prototype of the submarine or a mock up where they literally built to scale the portion of the submarine that we were working on the design. They put the decks in, they would put the equipment in. Many cases, the hull was made of steel. The decks were also made of steel because people were walking on them and such. But a lot of the equipment was made of wood. They had a prototype shop, and that's what they did. They also developed they being Newport News Shipbuilding, developed um, I'm going to go ahead and mark on this. They developed a virtual machining process, I'm sorry, a virtual computer process for looking at the submarine. As you can imagine, there's lots of piping, there's wiring, and so on, so they modeled all that. So they had the virtual in addition to that. Well, we can take that down in scale, right? We take that down in scale to individual components, plastic components, things like that. And you can still do computer modeling visualization. That was really due to the rise of solid modeling. So, oh, I don't like this at all. Oh, I'm going to turn that off. But under virtual, we would talk about solid modeling. And then the other option then was to machine parts using subtractive processes, which we're learning in this class in CNC. This generally wastes a lot of material and takes a amount of time, may involve additional tooling and things like that. So additive came along to kind of speed that process up, and I often refer to it as rapid prototyping. Um, as because that's what it was used for. But now, there's so much going on with additive, it's kind of evolved as a legitimate manufacturing process in addition to just a rapid prototyping source, although there are limitations. But in additive, we basically build material up layer by layer to make a finished product versus subtractive CNC removing material. And the idea behind this was to develop what I term touchy-feely parts. Many of the early additive manufacturing processes would give you a part that you could feel, look at. You couldn't actually test it or use it in the application, but additive manufacturing has evolved quite a bit since then, and there are actually now additive processes that make a functional part. So when we talk about additive, we're going to build the model up layer by layer, slice by slice, and there's various methods available, but this is the general concept. So if this is my part here, Maybe I can write on that. Okay, so this is my part here. Okay, here's the actual part, and I'm going to build it up layer by layer. This shows the slices, and using some method, I'm going to lay down the layers, and underneath I'm going to have a support because of the shape of this. This is a section view through. Within the section, I could have different densities, right? For the actual part, I could be much more dense, which is this is shown, and then this shows the support, which I want to break away when I'm done, isn't as dense. These are the standard additive manufacturing processes. Here, these are the most common, and there are variations of this. And then we go through, so this is the supply phase. What does it come in? For fused deposition modeling, it's not a liquid, it's actually a solid. So this lists the process, this lists the layer or creation technique. This shows what's happening to solidify it and what materials you can use. So stereolithography was one of the early, if not the earliest, maybe the first additive manufacturing. It was very expensive early on. It would basically take a liquid polymer. So here we have a liquid. Okay, this is my actual part here. Okay, and this is the platform. And the way this works is initially the platform starts right below the surface. So initially the platform is up here. Oh, that didn't work very good. Let's try again. Okay, well initially the platform is up here. Okay, and we put a thin layer of liquid. We drop the platform and let a thin layer of liquid cover the platform, and then we use this UV light source to cure the fluid. In other words, to take it from a liquid to a solid, which will cure it. And then we continue to drop the platform down layer by layer and cure the material, and the product is built from the bottom up. Okay, so that's stereolithography. It can use acrylics, epoxies, colorable resins, and filled resins. Pretty good, pretty strong, kind of brittle. These are mostly brittle materials, somewhat functionable. Next, we have selective laser sintering, which is down here, and this involves a powder. So we use powder, and then we use laser to basically melt the powder. And this type of additive manufacturing is actually used quite a bit in metals, but we're talking about polymers not right now. But you can use polymers, metals, binders, materials, ceramics, and sand with a binder. All can be used. So selective laser sintering is you have a box that you have powder, and we're going to feed the powder from the bottom. And we have a roller, and we use a laser to basically, so the powder comes up here. Oops. So the powder comes up here. Okay, we take the roller and we spread it over the platform. We have a platform in here, and then the laser burns or cures the shape of the part on the platform. Okay, and then the platform goes down, and the roller comes and puts another layer of powder over, and the laser sinters it again. And you have environmental control unit to control, because you're sintering stuff. your sintering material, so you can have smells and stuff, so you have that. But that's basically the same similar process, but we build it layer by layer from the bottom up. Okay, next we have ballistic particle manufacturing, and that's here, ballistic particle manufacturing, three-dimensional printing. You basically take droplet deposition. I'm sorry, these are separate. Ballistic droplet deposition, and you heat it up and melt it, and it basically cools, and you can use polymers and wax. So it looks like this. A stream of material such as plastic, ceramic, metal, or wax is ejected through a small orifice at a surface using an inkjet type mechanism. Of course, you're not really familiar with inkjets, but those were the basic printing techniques of years ago before laser printing came on and was a big deal. Same concept, we're going to build up layer by layer. 3D printing is very much related to ballistic particle manufacturing, but instead of the actual the material, we're depositing a binder, so a glue or adhesive. Same kind of concept. We have our powder supply. We're going to put it over the platform, and we're going to use an inkjet head to apply a binder, and we're going to construct our object. So if I go back to, that's here, three-dimensional printing. Ceramic, polymer, metals, powder, and sand can all be completed with that process. Next, we're going to talk about laminated object manufacturing. So laminated object, basically you're going to cut out paper or plastic sheets, and then you're going to glue them together, literally glue the shapes together. Not all that popular. This is kind of the idea. So we're using a head to burn things out, and then these are sticking together. Okay, and you know, like in any early processing, these were all tried. Everyone was trying to come up with the best method. And as it turns out, fused deposition modeling is by far probably the most popular now, especially in inexpensive or in the cheaper 3D printing, like the MakerBots and such they have at the library and we have down in the lab. And fused deposition modeling is really kind of neat. And the way it works is we move an extruder head in two directions over a table, and then we raise and lower the platform. And then we actually take thermoplastic filament, which is, you know, like a ribbon or a thread of thermoplastic material, and we put it through an extruder and we heat it, and then we extrude that. So this shows, and this is what MakerBot uses. This is a great example here. This is a great picture. So here's my ABS filament, and I go through and I actually drive the filament and I liquefy it in the extrusion head, and I bring it down and so I'm here. So I actually bring it through here, and then it liquefies and I drop it, and then this moves down and I build the part layer by layer. Okay, now something that becomes a big issue with really any of the 3D printing processes we have, and as I mentioned, this is by far the most popular, is that you have to deal with supports, because you cannot build structures in air, right? So you often have to have some type of support. Sometimes they'll make the supports in a weaker material that it can easily be snapped away, and this just shows some of the different supports. So let's say I wanted to build this T shape here. Okay, I can't build this out in thin air, right? So I would build support material here to gradually, oh, I didn't want to do that. Stop. Okay. I would gradually add material here so that I could build out. Here's another example. This is the finished part. Um, this is the support, right? Here's an arch, right? Here's a table. Now, what's a way around this? You build it upside down. You put this end on the base, and then you fill this up. Now, the problem with that is you're still going to have some support material. You may not get as nice a surface finish as if you build it this way. Same thing with this one, I could just flip it over. Same thing with this, I could just flip it over. So, but the point is when you design it, you have to think about it. Now, you may have supports inside your model. And in that case, we may have two extrusion heads, and we're extruding both materials at the same time. Okay. And when you want, when you need to build up a support, as in this case, you would be extruding this material, and then when you came over this, you would switch to this material, and so on. And that's a pretty popular method. And then there's various methods of getting rid of this. Years ago, I had a industrial 3D printer, and the support material was water soluble, so it would dissolve away. So you would take the finished part and you would place it in a sonic tank, ultrasonic tank with a fluid in it that would help to dissolve the supports, and the ultrasonic would help get rid of it as well. So you basically put the whole part in there with supports into the tank and run the ultrasonic overnight, and when you came back, all the support material was dissolved. So that's also another popular methodology. Well, let's take a quick look at a video that shows how the MakerBot a short time release video of a MakerBot building a part. And here it shows the structure getting built layer by layer. Now this is super fast, right? They don't run this fast. It's actually a very slow process. And the MakerBots is what we have over at the library, and when we get to Lab 4, that's what you're actually going to use. And that's it. Okay, and that concludes this video. Next time we're going to be talking about metal additive manufacturing processes.